Hi everyone, welcome you to the presentation of this video on nodal analysis. So in nodal analysis, we are interested in finding the node voltages. So we'll be given a circuit, then our interest is to find the voltages on the given nodes. So by definition, a node is basically the point of connection between two or more branches, whereas a branch represents a single element such as voltage source or a resistor. For example, when you are given this circuit, so in this circuit, point A, point B, and point C, these are the nodes, because these are points where the branches, this resistor is a branch, this 2 ohm resistor is a branch, this one, the current source, as well as that one. So a point where these branches are meeting is what we are calling a node. So in this circuit, you've got three nodes: node A, node B, as well as node C. So in this discussion, I'm going to explain how to find the voltages at given nodes. So you need to know that current flows from a higher potential, then it goes to a lower potential, given by that formula. So if you have a current like that, for current to flow, you're supposed to find the difference in voltages. The voltage at a higher potential minus the voltage at a lower potential divided by the opposition on that element or a branch, which is a resistor. So we're going to look at this example, which is saying calculate the node voltages in the circuit shown below. I got this example from one of the textbooks for electric fundamentals. So in this one, you realize that you've got how many branches? You've got, this is a branch, that one, that one, that one, as well as that one. But you only have two nodes, because these three branches are meeting at that node. We are calling this one as node 1. And these four branches are connected at that node. This is our node 2. So they want us to calculate the voltages at node 1, which is this one, as well as node 2. So what you need to do is you need to know that current flows from a higher potential to a lower potential. So at a given node, which is this one, you assume current movement. So for this one, for a 5 amp current source, already it's showing that it's coming in. So we know that current is entering this node. But for this branch and that branch, you can assume. So we can assume that at node 1, which is that one, of course, we've got two nodes, node 1 and node 2. So at node 1, we can assume that current is leaving node 1 going to node 2. And we can also assume that current is leaving node 1 going down to the ground, that one there. At node 2, also do an assumption. So if our assumption here was current is leaving this node, when you start assuming at node 2, current is supposed to enter that node because it was leaving there, so it's supposed to end. If you had assumed that it's entering there, then here it's supposed to leave. So since our assumption, we are saying it's leaving this node, it's entering node 2 like that. And then we can assume that here it's leaving this node going down. Then the 10 amp obviously is entering, as you can see from the current source. So with that said, and putting that in mind, saying current moves from a higher potential to a lower potential, which is this one, we'll be using this one as a governing equation for us to analyze our circuit. So we'll start our analysis at node 1. So if you look at node 1, which is this one here, you realize that we're going to apply Kirchhoff's current law, which says that summation of currents entering a node is equal to the currents leaving that node. So at this point, you realize that you've got the 5 amp, the one entering there, which is this one. So summation of currents entering is equal to the currents leaving. So those leaving is, you've got this one and that one. So for this one, the current leaving there, you're supposed to find the difference in potential according to this formula. So this one, since current is leaving, so V1 is at a higher potential, whereas V2 is at lower potential. So this is the difference you're having there. V1 minus V2, the difference between these node voltages, divided by the opposition on that branch, which is a 4 ohm. This is the one you're having there. So this is a representation of that current, the current leaving that node. And we have this current as well. So for this current there, you've got two potentials. You've got potential here and you've got the ground, which is 0. So it's the difference in the two potential, which is V1 minus the one going on the ground, which is 0, divided by the opposition, which is 2. So you have that one there. So this equation can be simplified. When you try to simplify this equation by multiplying throughout by 4, it becomes that. So that will be our equation number 1. Okay, so this is our analysis on node 1, at node 1. Then we can also analyze at node 2. So at node 2, we do the same. Currents entering a node is equal to the currents leaving that node. Okay. So at node 2, you realize that you've got current 10, which is this one entering. That's the one you're having. Plus another one entering is this one. And that is represented by this one. Higher potential minus lower potential divided by the opposition, which is this one. And then is equal to the currents leaving. Those leaving, you've got this one and that one. So the 5 is leaving. And the representation of the current passing through that resistor, which is this one. V2, which is the voltage at node 2, minus 0, because this is the ground, divided by 6, which is that one. You're going to have that. Simplifying that equation, we are going to have this as our equation number 2. So our analysis is done. Analysis at node 1, we have that equation. Analysis at node 2, we have that equation. What we are remaining is just to solve those two simultaneous equations, and then we're going to have our V2. So we are solving equation 1 and equation 2 simultaneously. I'm using elimination method. So I can eliminate the V1 since they have the same coefficients by subtracting 3V1 minus 3V1. It will be a 0, of course. It will go negative that minus that. It's going to produce 4V2. Okay, and then 20 minus negative 60 will produce positive 80. Then we'll divide both sides by 4, which is this one there. We're going to have the value for V2 as 20 volts. Once we have 20 volts as V2, we can just pick any of the equations, either equation 1 or equation 2, make V1 the subject, and then we'll be able to solve for V1. So I chose equation 1. From there, I make V1 the subject. I'll have this one. Since I have the value for V2, which is 20, where there is V2, I put 20. It becomes that, and we're going to have V1 as 13.3 volts. So this is our analysis on nodal analysis using current sources. In the next presentation, I'll be talking about nodal analysis where you've got voltage sources. So I'm going to introduce a term which we're calling a supernode. Thanks for watching.